Hello, people. I'm back. Not with Unreal, because Unreal was getting on my nerves. So I decided to do some Unity. And I'm just checking my music. Sorry. I want to do some ECS stuff again. It's been a minute. And recently, I was playing this game. Oh, wait. Just now I got a message on Discord. When and where and why? Didn't. One second. Hmm. Why does this not work? Hmm. Huh. Okay, anyway. What was I saying? I was playing recently a game. Lords and Villains was the name. Let me see. Lords and Villains. Yeah, this game right here. And I like the concept quite a bit, but the the performance was just horrible, really. And I'm not really, I don't understand why, because the game clearly wants you to have like lots of pawns. It's a RimWorld type game. It wants to have you a lot of pawns, a lot of families that hang around your city and do stuff. And I got to like 50 maybe. And from then on, it was just unplayable. It was a slideshow. And like this is how they advertise it. Yeah. So this is already a lot of stuff with a lot of people. Supposedly, you just count the bets. There should be like 30 people in here. At least. But when you actually get to that number in the game, it's just unplayable. It's not like I have a bad PC. It just doesn't work. And that reminded me of RimWorld, which has similar problems. Like you get to 10 pawns or something, and then, you know, the game gets a little bit sluggish. The maps you can play on are not very big. They're like 128 by 128. So when you have like 20 to 30 pawns, like animals and enemies and your own, then the game gets very wonky. And I'm wondering why that is. So what I want to do is test this concept in ECS, like a little colony builder. And yeah, just see how many pawns I can simulate. Obviously, I'm not gonna make a whole game here. Or maybe I will, who knows. But I just want to see, yeah, how it performs. So I've started with some pathfinding. So I've implemented a little A star quite a while ago in ECS. And I want to see how many paths I can find on a stable frame rate, because I think that's really the biggest, the most expensive thing that's going on is pathfinding for all the pawns on your map. So I want to see how this performs. Um, and I'm aware that these games are probably not using an ECS system. But I mean, there's still things you can do to make things fast even without ECS. It's really just a multi-threading tool. Okay, so no, we don't want to update now. Let's see, what did I do? I have to recollect my thoughts. What are you importing? I haven't changed anything. So I have this static A star class here, which can be called normally and from ECS systems. And I just want to make sure that this works the way I expect it to, because I wrote this like 2 years ago or something. I'm not even sure when or why. I just remembered that I had it. So I have placed some nodes that are connected. And I have to feed these nodes into my A star algorithm. And this is generic. So we have a graph that has some functions: estimate distance, get transition. Shouldn't this T? Oh yeah, no, we give this T right here. Graph node. Oh, so this node is just a component. Probably could. Maybe there was a problem with interfaces in ECS. I'm not completely sure. Let's see. I will start by writing just the unit test, I suppose. I have some other stuff in here. That's not stress test. This is the example scene, I believe. Where am I? Yeah, example. I have some tests here. A star test. These are all commented out. I put them back in. Node float 3. I have to reorganize all my namespaces. I do have this class somewhere here, node float 3, yeah. Let me just make a new folder. Create folder game. And I put everything in there. A star. Okay, let's make a ASM def. I'll just call it game. Okay, and then I need actually make one more folder. Called implementation, whatever, doesn't really matter. And then I want to pull the tests out. And give this a reference to my game code. And then it should be able to resolve the things. Let's see, A star system. What is your issue? I'm pretty tired today. I feel tired for some reason. Oh yeah, I need... why is this now here? Let's close Visual Studio. We of course need all the references to the entities. So we need entities, Unity entities. We need, I think there was one more, like collections or stuff, something. Hybrid? Hybrid, I think we need hybrid. Yeah. Put these in, see what it says. Entities does not exist. Hmm? Hmm. What can you not find? Hmm? Oh, no, it's recompiling. Okay. There's no Unity burst. Again, created these folders. Maybe I have to restart the project. I mean, restart Unity. Oh, uh, and why can't I do stuff while Visual Studio is opening? Huh? Let's see. Bursts. Burst. This. Delete this. Unity collections. Yeah, I knew there was something with collections. Collections. Unity. Oh, Unity collections, not entities collections. Okay. I did add the Unity collections thing. Why is it not recompiling? Is there anything else missing? Oh yeah, mathematics. Mathematics. Like this. It doesn't want to recompile for some reason. Node 3. Native hash map. Yeah, let me just restart this. Hmm. Yes, enter in safe mode. Somehow my hair is annoying today. On aspect. Oh yeah, we need transform or something. Unity transforms. Probably also transforms hybrid. Is it compiling? It's not compiling. Why is it not compiling? It used to compile every time I changed this, but not anymore. Is this the bug in the new version? Hmm. I'm really tired. I don't even know why I went to bed early. Slept quite a long time. Okay, now we have successfully compiled, it seems. Okay, let's check out these tests. Okay. Don't need any of this. So one step. Node float 3. So this is just the node which has a float3 vector essentially as its position. We don't need this. There's a better way to do this now. Hash code, combine, value. Since it's a 2D game, probably don't need 3 positions, but that's okay for now. Okay, so we create a node, create another node, create a dictionary of node to an array of nodes. Start equals new array, which just contains the goal. Graph load 3 managed. So this should be our graph, which has all the estimation functions. Get transition. What is? Oh yeah, we can mark it as read only. But whatever. Transitions contains key node. Okay, so this gets all the neighbors. And then we find the path, and then we should just go from start to goal. So we get the path returned, and it should just be start to goal. Window general test runner. We should find the test in here. Once that. And that works. Start equals goal. So we just have one node. Test that. That seems okay. And two-step. We have a start. We have 2 nodes and a goal. And the start is connected to A1 and A2, and A1 and A2 are connected to the goal. And A2, so A1 is directly in the middle of start and goal, and A2 is a bit off center. So A2 is longer. So we expect the path to be start A1 goal. And that also works, okay. Are there any more tests that we want to do with this? Oops. This needs that. Another case that we could test. We haven't tested any negative numbers, which could be interesting. Just make a copy of this and invert all the numbers, which should result in the same thing. Yeah, that's good. Should also make a test for when there's no path. Let's see. Find path. What happens when there's no path? Should just return an empty array. Probably. Find path. Yeah, it returns default. So let's get this and say no path. Let's take this like so, and we say there's no connection to the goal. And then we should get a length of 0. Maybe it would be better to return the state like an enum that says path found or path not found instead of just an empty array. Maybe later. So this should just be 0. Yeah, okay, that works. Oh yeah, I probably should also test the graph with a loop. That should also work, obviously. So let's say let's say goal is also connected to A1 and A2. Maybe let's just do a fully connected graph, except for start to goal. So A1 is connected to, wait, how did I do this? A1, yeah. A1 is connected to A2 and goal, and A2 is connected to A1 and goal. Start is connected to A1 and A2. Goal is connected to A1 and A2 and start. So these are one directional edges. So just because you can go from goal to start doesn't mean you can go the reverse path also. So this should be the same as the two-step. Just making sure we're covering all our bases. I don't trust past me. But it seems like I did an okay job at least. It does what it says it would. Um, Anything else we should test? No, I think that's about it. Okay, so this seems to work all right. Then I want to do a stress test, I suppose. I did see. Why is this again here? Why does it keep creating empty folders? Like there's nothing in here. Why are you doing this to me? A star. Go away. We don't need or want you. Or is it Visual Studio that is creating these? Um, no, I don't see it. Hmm. Hmm. See a reason why it would always recreate these folders. Okay. Wait, where's my stress test? Here. Let's see what this does. Nothing, because it's all commented out. Let's see what it should do. Entity manager. We get the default world. Nodes. Entity. Create entity manager. Add component data. Okay, we create a bunch of random nodes. And then we create a bunch of random transitions. Nodes. We just do random int. What was it? Random range. No, random dot range like this. 0 to nodes count. Random connections for each node. Transitions per node. Oh, that's set in the inspector. Okay. Update find path per frame. Get a random node from. Get a random node to. Entity manager. Create entity. Find path component. Okay, and the A-star system is triggered using this component. And I think I have to update this because ECS has changed. Let's see. Find path drop. Now I have to remember how we write systems now. Move system, for instance. Ah, yeah, we have partial struct like this, which needs an aspect or just a component, I suppose. Wait, find path component. This one. Find path. And this needs a lot of things. Try and take this, put that in here. And oof, this is no longer correct. Component from entity. I don't think we need any of this. We just create the job and schedule it. Do we need a command buffer? Transition lookup. Graph. Oh yeah, this needs a graph, obviously. Struct. Transition lookup. We shouldn't create a new graph here. This graph should just be wait. Oh, how did I intend to do this? In our system, we have to find all the nodes. So, yeah, I think transition lookup. Wait, what's the best way to do this? The node float 3. System API get component lookup. Gets a dictionary like container containing all components of type T. This sounds like what I want. Node float 3. And this returns a lookup. Component lookup. And how do we... How did we create the transitions? Stress test, yeah. Dynamic buffer, no transition buffer. So this seems important. Entity node. Buffer element data, an interface for creating structs that can be stored in a dynamic buffer. No transition buffer. Transitions. Transitions at okay, so we create this no transition buffer, which is a dynamic array, a list essentially for ECS, and we attach it to the entity. So that is where we should get our transitions. So our system. So I think I want to create an aspect, unless I already have one. No. Let's create a node aspect. And this is going to be... I have to look it up again. How did we make aspects? Like this. Read only partial struct. Implementing this interface. And then we can have ref ro things. Public read only, ref ro, node float reposition. And let's see if I can do the same with the dynamic buffer. Node transition buffer. Oh wait, or do I have to do dynamic buffer like this? Maybe. Transitions. Okay, that doesn't work. No transition buffer. Is there a ref ro? It has to be a struct, a component data. Hmm. Maybe I just use it directly? No, probably not. Oh, maybe. Are you okay with that? I will be right back. Okay. What's this? Buffer lookup. No transition buffer has component entity is obsolete. This method has been renamed to has buffer. This relevant? Yes. So this I think this already does the lookup of the transitions, but buffer lookup native container that provides access to all instances of dynamic buffer components with elements of type T indexed by entity. Buffer lookup is a native container that provides array-like access to dynamic buffer components of a specific type. For example, while iterating over a set of entities, you can use buffer lookup to get and set dynamic buffers of unrelated entities. To get a buffer lookup, call system API get buffer lookup as a buffer lookup container to a job by defining a public field of the appropriate type in your iJob implementation. As a buffer lookup container to a job by defining a public field of the appropriate type in your iJob implementation. You can safely read from buffer lookup in any job, but by default you cannot write components in the container in parallel jobs. You know that two instances of a parallel job can never write to the same index in the container. You can disable the restriction in parallel writing by adding native disable parallel for restriction attribute to the buffer lookup field definition in the job struct. So I think it tells me to not put it in an aspect, but as a public field. Transitions. But we can still use the aspect. I think there's no harm in using the aspect. But it doesn't want to use it. Is there another lookup? No. Okay, then I guess we have to use this. And this should be injected automatically. Maybe. Graph transitions. Oh yeah, and we have to add this here. And this we have to set lookup equals lookup. This goes in here, I want to say. Component lookup, yeah. Let's call this maybe nodes. Nodes, transitions, yeah. Makes more sense. Command buffer. Remove component. Find path component. Ah, yeah. So we need the command buffer to remove this action. We don't find the same path over and over and over again. Hmm. Hmm. Maybe it would be. Oh, I got another message. Did I see this in time? Yeah. 1 second. Jeez, Discord. Why are you so inconvenient sometimes? Why doesn't that take me back to the message that I was just looking at? Okay. So we need a command buffer. Sorry, I'm waiting for Discord to do something. System API command buffer. Is this where I create a command buffer? No. Why are you not responding? Huh? Hmm? The fuck? Come on, guy. I have things to do. This is what you said? Stellaris gets a new DLC. Okay. Okay. Fuck this. Or do I just do command buffer? Oh yeah, there was like command buffer system. I think I have to look this up. Let's see. Wait, where was the link to the documentation? Um, command buffer. dynamic buffer. Entity command buffer overview. An entity command buffer stores a queue of thread safe commands, blah, blah, blah. We know that. The methods in entity command buffer record commands which mirror entity manager. Yeah. Temporary entities created by command buffers. Yeah. Use an entity command buffer. Okay, so I just literally instantiate a new one. Oh, but this is I think this is out of date. Entities for each. I don't think we do that anymore. Entities. Yeah, we don't. So this documentation is not up to date. Right. So good. What's the word? A good way to start. Okay, so we do the ECB. I think we probably just injected. We'll have to. What the fuck happened there? ECB. ECB is ECB. ECB. Remove component. This. Can we just remove this? Remove. Oh, we have to also have the entity. Or can I just say destroy component? No. Okay, so I also have to get the entity. I think we can just do this. Entity. Remove component. Like that. Rest is created. Okay. Stuff, find path. Oh, this has a is created. Maybe I should check that in my test and not the length. Anyway, dynamic buffer, path buffer. Oh, so then, we remove the find path component. We add a path buffer. So this is the path that we found. And then we add all of the nodes. So I think what would be better if If we didn't have to add and remove these. So in reality, what I would do is I would add the find path component to the entity that needs the path, like my pawn. And I would also add the path buffer to that same entity. So there's no reason to remove that component. I would just say find, like set a bool that says find new path or recalculate path. And only if that is true, I would recalculate the path. I think that's much better than adding or removing the components. Add buffer entity. And then we go through all the nodes and create buffer element data. This should probably also have the actual node data, this node flow 3, instead of just an entity. Okay, anyway. Let's see if this compiles. Unity says it's okay, apparently. And then in the stress test, let's see if this does anything at all. Find path per frame 100, node count 100, transitions to node 5. I now start this. Then we get an error. Okay, invalid operation exception. System invalid operation exception. Get singleton requires that exactly one entity exists that matches this query. Oh, this is from a different system. What was this? I mean, I don't have that many. I think it was either move system. No. Then it is. Ah, yeah, spawn system, which I use in the other. In the other scene. So here I want to say, what was it? On create. There was some way to say like state require singleton for update. Yeah, that's the one. Spawn data. Oh, obsolete. Use require for update. Okay, require for update. Okay. So that should take care of that. Try again. One more error. Object reference not set to an instance of an object. This exception was thrown from a job compiled with burst, graph load 3, transition lookup. So this is probably null, which means this is null, so this is not injected automatically. But it said has a buffer lookup container to a job by defining a public field of the appropriate type in your iJob implementation. You can safely read from the buffer lookup. Okay, so maybe I have to create this first here. Transitions equals. Do I get one? Is this like get buffer lookup like this? Is read only? Yes. This is also read only. Yes. Make everything read only. So this is the nodes and transitions equals transitions. Anything I have to set here? Allocator, payback policy. No, that should be fine. That should be fine. Try again. Still invalid operation exception. Component lookup node flow 3 must be marked read only in the job a star system job because the container itself is marked read only. The component lookup has to be marked as read only. So it wants me to do this. Unity collections read only and probably also this. Ah, yeah, because now I added the read only here, so I have to specify this is read only. And I'm not sure if this is accurate anymore, but I should probably also do this as in to mark this essentially as read only. Because we're not changing anything here. We're just adding it to the command buffer. There's still one more thing. Invalid operation exception gets in and requires that execute. Did we fix that? Let's disable burst. So we can get a better error. Map spawn system. Ah, yeah, same thing. Same thing here. So this needs also spawn data. Okay. Let's see. Okay, we get some warnings. Job temp alloc has allocations that are more than the 4 frames out. To debug run app with right. Safety check. Do I find this here? Assembly. Oh no, this is just Generate code. Safety check. Drop temp alloc. This in reference to my command buffer, maybe? Oh, I think I have to, at the end here, do like this pose. Let me check the docs. Yeah, this calls this pose. Dependency complete. I don't know if this is accurate anymore. Oh wait, there's newer documentation. Oh, but this is still the same. ECD playback. Now that the job is completed, you can enact the changes. Note that the playback can only be called on the main thread. But I use the schedule here. Schedule entity query depends on dependency. Dependency complete. I don't think this is. Yeah, no. Oh, wait, maybe it's state complete dependency, complete combined job handles registered with the system. Um, mm, mm, System API complete. Okay, let's try this. State complete dependency. I'm not sure this is the way to go, but it may fix the warning. Yeah, it does. Okay, so we are running at 1 frame per second. Let's see if this actually works. We have lots of entities. Oh, I can't. For some reason, this also doesn't work anymore. Like I should be able to see these entities in the inspector. For some reason, I only see the hierarchy things. I feel like there was a time where this used to work better. Old world. I cannot inspect the entities, which is bad. Let me Google this. Unity and inspect entities. In 23.2. Yeah, I'm not the only one with this problem. Recently, I picked up ECS using Unity 2022. For a work project there, I was able to click on an entity in the entity's hierarchy and see its runtime data in the inspector. Now, for personal project, I wanted to check out 2023. Notice that now whenever I click on an entity, the inspector says absolutely blank. Did I do something wrong? downgrading fixes it. 23 isn't officially supported yet, but I do have a fix on a fork for this. Something in the order of callbacks changed. And UITK. And now it's called calling the deselect after the select instantly clears your selection. I see. Okay, so I have to use 2022. If you install entities 1.2 preview package, it works. Okay, so let's just update to the preview package then. Entities. How did I allow preview packages? Project settings. Project settings, package manager, enable pre-release packages. Yes. And then I should be able to see more versions of this. Reload. I don't. Version history. Why can I not see the preview package? Entities. Why does it not show 1.2? It even has the 1.3 preview, 1.24. Why can't I find this? 1.24. I'm on 1.016. I'm on this. I can neither see this nor this. Why? Doesn't show. Working in the editor. Does it say somewhere which Unity versions are supported? I would assume that if this is supported in 2022, it would also be supported in 2023. Okay, so I guess I have to downgrade my Unity version to 2022. Okay, then let's do that. What's the worst that could happen? Yes, change version. versions are always great. As an industry, we haven't figured out versioning in like 50 years. Something is always, ugh. This version is not compatible with that version, and you need this version to do that thing. Oh well. Okay, so this is gonna take a minute. So I'll be back in a minute. Okay, I think we're done. URP material upgrade. Materials in your project were created using older version of URP. Okay, sure. Something did not work. Anyway, let's just update everything and see what happens. This is all taking a while. At least compilation times are short, I guess. Ah, okay. For a moment there, I thought I was putting the feet up. Okay. Also update this. Anything else? Doesn't look like it. So we're already at 1.2 entities. I didn't even know. But the documentation is still very sparse and also not up to date. Okay, so we got all the things. Unable to update the following assemblies. Next. Okay, that shouldn't be updated. An error occurred while resolving packages. Unity modules accessibility. Project has invalid dependencies. Accessibility project. Okay, then just remove it. I don't see why I would need that. Okay. Oh, and it reset my layout. Entities hierarchy. This one I need. Hierarchy I need over here. Also need more systems in there. I don't need my audio mixer. Anything else? Components, system archetypes, journaling? No. Okay, so this should work now. We're in the correct scene, stress test, yes. Then let's start. Solid 1 frame per second. Uh, node flow. Oh, this one. These are our nodes. Find path. Simulate. We have lots of find path components. I don't see any path buffers in here. This is a node transition buffer. So this seems to work fine. Let's see. Let's not say remove component. I will just create some find move components at the beginning. So these would be my pawns, and I would just say bool recalculate path. And if this is false, I don't do this. Find path, recalculate path. Then just return. So this will still execute for all my pawns, but that shouldn't be an issue. If my goal was I want to have like 1000 pawns, so this would get called 1000 times per frame. On the other hand, when I remove the find path component, this takes longer in the frame that the path is actually being calculated. But afterwards, it wouldn't be called at all. So it's really a question of what is faster. Now that I think about it, I think probably removing the component and not executing this at all, probably faster. Okay, let's stick with the removing. But instead of creating new entities every frame, let's create like 1000 entities in the beginning. So I would say public int pawn count, and then we say for int e pawn count we create some entities and we say private list entity pawns is new pawns at e And then in find path per frame, we want to look at all these pawns and add a new find path component. Find path per frame. So we want to find the first one for int j is null, j smaller pawns count. Entity manager as component. Pawns j. So if we do not have a component here, then we add one. We do this, but for this guy, and then we break. But we want to store the j. We don't look at the same pawns over and over again. So let's say int j is 0. We do nothing here. Find path per frame. Yeah, I think that would work. And then these get removed from the system and but we can add a path buffer. So we don't have to create one every time. Entity manager add buffer, path buffer to entity. What's the problem? Dynamic buffer. Entity manager add buffer. It's dynamic buffer. Oh, it needs just buffer element data. So this path buffer. Okay. And then in the A star system, we don't add that buffer. We just have to find it. So I guess we say in dynamic buffer like this. And then we have to say buffer clear. ECB clear buffer. Or append to buffer. Set buffer. Records a command to set a dynamic buffer on an entity. Can I just say buffer clear? But then it probably can't be in, but must be ref or something. Let's see. Let's see if this works. I don't think it would. nothing is happening. The entities have not been... Oh yeah, because I haven't set a number in here. Test. Let's start with 1. Transition buffer. So these are our nodes. Can I set the names? Just as create. Is there like an E name or something? Apparently not. But our entity, our pawn should be the last one. Path buffer. We're still at 9 frames. Oh, and we also have exceptions. Invalid operation. Buffer type handle path buffer has been declared as read only in the job, but you're writing to it. Okay, yeah, so this does not work as expected. So this can't be in. Remove component. Buffer clear. Okay. Why is it not creating anything? Oh, no, here we go. So that is our entity. For some reason, it only does this. These never change. Why do they never change? It's just this. These, the find path component should get removed and then added again. PCB, remove component. Oops. No, I opened Godot. Wait. Let's just do this once. And then the find path component should get removed. It's again not... Why? What's going on? Now it works. Huh? No, this is still here. This shouldn't be here. Star system. Count 1. For some reason, this doesn't do it. But we do get a path. 110, 61, 121, 49. Yeah. So it does do the pathfinding correctly, but it does not remove the find path component. Hmm. State complete dependency. Completes combined job handles. I have to put something in here. Query job handle depends on. The handle identifying already scheduled jobs that could constrain this job. A job that writes to a component cannot run in parallel with other jobs that read or write that component. Jobs that only read the same components can run in parallel. It does not do this for some reason. Let's check the docs again. Let's go to 1.2. This hasn't been updated in a while, huh? If you want to use an ECB in a parallel job, use entity command buffer parallel writer, which concurrently records in a thread safe way to command buffer. Or maybe I need this one. Entity command buffer parallel writer. Entity command buffer dot parallel writer. Any arguments? No. This doesn't have a dispose. Only recording needs to be thread safe for concurrency and parallel jobs. Playback is always single threaded on the main thread. Oh, ECBS parallel writer. So I need this. And then I do this. And then I pass that in here. Remove component. Oh, that is why I had the entity index and stuff in here, huh? Record the command to remove component of type T from native area of entities. The entity to remove from sort key. Unique index for each set of commands added to this entity command buffer across all parallel jobs writing commands to this buffer. The chunk index query provided by iJob entity is an appropriate value to use for this parameter. An iJob chunk has the unfiltered chunk index value from iJob chunk. Execute archetype chunk in bool unity. Okay. Chunk index in query. So this is what I need, provided by iJob entity. So is it like chunk index in query? I just do this? Specifies that this in parameters used as in chunk. Oh, wait, this is an attribute. So I do this int index index like so. Let's see. It didn't create the entities again. What? Or is it just a problem with the window? This is still not being removed. Buffer 8. Oh, of course the path is different. Because the nodes are generated randomly. Hmm. This is still not being removed. Why? Parallel ECB. Is there anything on here? Add buffer, add component, create entity, destroy entity, remove component, set name. So there is a set name. Let's see. Entity manager set, set name. E on I. Aha. And let's do the same here. No, wait, here. In for the nodes. No. Doesn't show the entities, but they do seem to exist, so not sure what's going on. Okay. Okay, so that's cool. Doesn't really solve the problem at hand, but that's nice. If I don't do this, then it will just... Maybe I have to do a parallel schedule or something. If I do this, then I get the warnings again. Why do you not show my entities? Fucking hell. Why is this window so janky? This still doesn't work. Wait. Command buffer. Wait, wasn't there like a command buffer system? Command buffer system. Begin, end, fixed, end simulation, entity, command buffer system at the end of the simulation system group. This system, a star system simulation system group. I think I have to use this, create command buffer, because otherwise it doesn't know when to replay. Low level unsafe entity command pending buffers. Creates a command buffer that allocates from a world update allocator, sets it up in a pencil to list of command buffers. Uh, hmm, 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 hmm. Command buffer. Hmm. Hmm. Maybe system API get system. Wait, state system handle. Should run system. Entity manager get system. How do I find the systems? Wait, or was it schedule state system handler? Do I have to pass this in here? No. Job handler. Hmm. Dependency. Do this. State. Dependency. Complete. I would think these are the same. Ensures that the job has completed. Completes combined job handles registered with the system. Maybe that is what's missing. I mean, this right here also just instantiates the command buffer and then calls playback in the end. Maybe I have to call playback manually, but invalid operation in the previously scheduled job as a job writes to the Unity entities. Command buffer must call job handle complete on the job. Uh, um, let's see. I just call ECD playback. Tutorial says to just do this. No, previously scheduled job writes to entity command buffer. Yeah, I'll just call both of these. Maybe that does something. No. Hmm. So these don't do anything. State dependency. Huh. Entity command buffer playback. Update. State dependency complete. Playback dispose. That doesn't work for me. Drop. Just use a schedule without this. And state.dependency.complete. So not this. So this is, I do the same thing as they do in the documentation right here. Instantiate with temp job, parallel recording job, ECB as parallel writer, dot schedule, dependency complete. It's the exact same setup. require matching queries for update. Okay, let's do this one more time. One more time. Oh, now it works. Huh, interesting. So, now this has been removed. So that is what I wanted. Okay, so just schedule, dependency complete, playback. Um, okay, so I guess this is good. Good like this. Um, okay, so if we now say this, then it should always look for new paths if I'm allowed to. Oh, I just have to select the default world. Okay. Okay. So does the thing repeatedly. We're at 200 frames, 200 to 30, something like that. Fluctuates a lot. Simulation group. Yeah, the A star system takes a long time actually. 1 millisecond. Oh yeah, let's re-enable burst compilation. See what that changes. Instead of A star, I could also use like Dijkstra and uh, just store all the paths that I've ever found and then just look them up again instead of recalculating them all the time. And then I just have to recalculate the path when the map changes, which might be faster. Okay, so this is actually slower than before. Where's my A star system? Here. No, this should be much faster. Okay, yeah, now it is faster. Delayed update. And now we're almost at 300. Okay. So let's see if we increase this to 100. So every pawn gets a new path to look for every time the last one completed. We're still at 100 FPS for 100 pawns. Just doing A star constantly. And this is now 4 to 5 milliseconds. That makes sense. So if we say 1000 pawns, but we still only calculate 100 paths per frame, and we're still at 100 FPS. So that's really, pathfinding doesn't seem to be an issue. There's no game like this would ever calculate 100 paths per frame. Yeah, we are calculating paths like crazy. And they're all of varying sizes. Okay, so these actually only ever do the first 100 because on the frame we set this to calculate. That's also calculating the path and then removing the thing again. So let's see. This is 4.4 to 5.5, kind of in that range. But if I were to get the bool here, bool calc, and say if find path calc not, then just return, and then I don't remove this. I say ECB set component enabled records a command to enable or disable a component type in the specified entity. This operation does not cause a structural change or affect the value of the component for the purposes of entity-query matching. An entity with a disabled component will behave as if it does not have that component. Oh, that would actually be even better. Set component enabled, find path component, index entity false, like this. Sort key entity value, find path component. It's not compatible. Why not? Set component enabled. Oh, enableable component. So like this. And then I don't need this. Set enable to false. And then in here, when I say, hey, find the path again, I want to say entity manager manager set component. Just set set component data. This. Oh yeah, entity pawns J, and also entity manager set component enabled pawns J, component type true, like that. So we were between 4 and 5, 5.5-ish milliseconds before. Let's see if this works. Component with component has not been added to the entity. Oh yeah. So now I have to add this to every pawn. Add component data e just wait. Just an empty component. Does this work? No. Then let's find path component like so. Still, the entity does not exist. Hmm? What? Hmm? System argument exception. Component lookup. Let's disable burst. Put this down to 1. Okay, I think we have to restart to get rid of these messages. Restart. So when I disable the components, seems like component lookup. No, right. Index entity find path component. Let's start. The reference script unknown is missing. What? What script is missing? System init. Oh, yeah, this is probably not needed. Argument exception. The entity does not exist. Entities journaling may be able to help determine more information. Look up a star 27. Some entity does not exist. Hmm. Wait, 16 node? Huh? Wait, huh? Why is this 16? Huh? Oh, yeah, this is just the capacity, the initial capacity. Yeah, okay. Maybe let's put that in a const. Private const in initial capacity 16. Okay. That doesn't explain which entity does not exist. A star system 13. A star system chunk entity 35 from to graph. Hmm. Hmm. Start node, goal node. The nodes don't exist. What? Node for 3? Haven't changed anything here. Hmm. Hmm. The other one tries tracker by handle can only be called from the main thread. Structures and field initializers will be executed from the loaded thread. When loading a scene, oh, a star system 13. The fuck? Hmm. The entity does not exist. Okay, let's check the journaling. Oh wait, it also closed all my other. Huh? Why do you close my windows? Stupid Unity hierarchy. Oh no, not hierarchy. Systems. Okay, so we're here. The entities are all here, but these are not being set. Hmm. Did I make a mistake here? From to set component data. Maybe this somehow interferes. Simulate. Maybe I have to first do this and then first enable, then set the data. Maybe enabling overrides the data somehow. No. What the heck? I don't do this at all. Once J, this is exactly the same as I did before. Oh wait. I have to set this to false initially, so it doesn't try to find a path for nothing, yeah. And then it just gets stuck because it never sets it to false because the system fails to execute. Okay. So here we are. Default world. This gets never re-enabled. Why is that? Oh, because I do has component. Because there is component enabled. Yeah. If this is not enabled, then we set new data and then enable the component again. Okay. Now we're back in business. And we are running at 240. Paste the system back at like 1 millisecond. So we enable burst again. Oh, and we have an error. Internal compile error. Not find file. Huh? Okay, maybe I have to wait for burst to be done. Maybe. Okay. Okay. So now we are back at 0.1, 0.09, 0.14, 0.13-ish. And when we do our 1,000 pawns again, we were like at 4.4, 5.5 in that range. Yeah, that doesn't actually change a lot. Yeah, it's still kind of the same. So removing a component or just disabling it doesn't actually make as much of a difference as I thought. Paste the system. We set this to false. Hmm. Hmm. But I guess it's still the better way to do it. Seems a little bit cleaner. Huh. Hmm. I'm still not sure about this command buffer thing. That doesn't seem super correct. I vaguely remember that it used to be the case that you select the group for your command buffer, like and simulation group command buffer, and then that is where the command buffer would replay. Maybe that's not a thing anymore. Because when you did it like this, it waits for the job to finish. And then this job would block all the other systems in that system group. I think that's how it used to be. Let's take another look at the systems. So simulation group is pretty much only the A star system. Hmm. So we're still at 100, 110 frames. We have 100 nodes. I set this to like what would be a decent map size. Maybe 1K times 1K. That would be 100,000 nodes. It's a decent sized map. One could say a huge map even. Does this change anything? Oh yeah, it obviously takes longer to initialize all the nodes. But the question is if the A star runs much slower now, which it shouldn't. I mean, should be a bit slower, but not a lot. So this should still be manageable, I would say. If we ever get there. 100K nodes is a lot to initialize, apparently. Like the biggest map sizes I see in RimWorld or other games like that would be like 256 by 256. I want to say, and that's already pushing it. It's mostly more like 64 times 64. Oh, okay, that's maybe 100K was a bit ambitious. Hmm. Oh yeah, and we also have to initialize all the connections. 5 per node. So that's another 500k entities. Not entities, but buffers, arrays, lists, or all the. So yeah, each node gets one buffer of transitions. And yeah, five transitions per node. Hmm. Do I want to wait for this? Maybe 100k was too much. It's a lot of entities, even though they're very small. Let's see what the task manager says. Hmm. 6 GB. Okay, I guess this was too big. Too much to initialize. Let's kill this, I guess. And try a bit of a lower number. Like let's, what did I have in the beginning? 100. Maybe let's try 1k. What is 64 times 64? 4096. Okay, let's try that many nodes. Four thousand 96. That probably shouldn't be a problem. Let's wait for burst to do the compile. Do the compile burst. Okay. Okay, so that was much quicker, but our FPS are in the shit. It closed all the windows. Oh yeah, because I killed Unity. This time it's not Unity's fault. Entities, hierarchy. So I believe this takes a very long time because we can't find any path. because we just don't have enough connections. No, we do find paths. Yeah, yeah, we do. Hmm. Okay. So that's very slow for some reason. Go down to 100 pawns. The other 900 don't do anything anyway. Hmm. 4096. 1000 MS. Hmm. So that takes a very long time for a graph that's a little bit bigger. Hmm. So what we do right now is we just place random nodes at super random locations, which is not really what a 2D map looks like. To make this more realistic, we could just create a a proper map. So we don't say node count, we say vector 2int map size. Map size X and map size Y. I also wonder if it would be better to have all the nodes in one entity as a buffer. That probably doesn't really change anything. I mean, in here we do get component lookup, which gives us the component lookup. Question is, would this be faster if it was just all in one entity? Maybe it would be. Let's do this one first. So we create our map. We don't need transitions per node because we just connect all the orthogonal nodes. So this would be X, Y, and 0. Node X, Y. And then after we created all the nodes, we wanna let's store the nodes in a list. Oh, we already do that. So we can just iterate through the list for each entity in nodes. Oh, that's actually what we do here. We create a new buffer. We don't need this, and we just have to find the neighboring nodes. So we say, let's actually store. No, that's fine. Say entity manager, get component data, node float 3, position. Component data. Oh yeah, we have to say from which entity. And then we say position if position x greater than 0, then we need, oh yeah, value x greater than 0. Then we add a transition private entity get node at position int x and y. Position value x minus 1 and y. Pass this to int. Transitions at. Oh, new. And what did this need? Entity. New entity is this. Let's call this n for neighbor. This is entity. Entity equals. Oh wait, node equals n. Okay, like this. If x is smaller than. I didn't get the right. What the fuck? What are you doing? Oh, missing one brace. If we are smaller than map size x minus 1, then we add a +1, and we need the same thing for the y. Oh, wait, x, y minus 1, and y +1. Okay, that is all we need. And then here we just say for each node and nodes. This is super inefficient, but it's not really what we care about right now. Get this. Note. And if position X equals X and int position Y equals Y, then return that, oh yeah, dot value, dot value. I am missing one or one too many. And if we don't find one, we just say throw new exception. And that should do it. We create all the nodes in the X and Y position and then add the neighbors for each. Which should give us a very map that's very easy to navigate for A star. Because we shouldn't have to backtrack as much. So let's start by with 10 by 10. See if it works at all. Yeah, it works. It is quite a bit faster than random nodes. I deselect all of this. 7. Why is it 7? I guess there's other stuff running in the background for the editor. So if I say 64 by 64, then there's a lot more nodes to initialize. It is faster than before. 150, quite a bit faster than before, like 10 times. 6 FPS. Let me try something. If I set one of these to 1 and make this 1096, then we have the same number of nodes, but it's all in one line, which should be very fast to pathfind on. It doesn't really make a difference. Makes a bit of a difference, but not as much as I thought. Since if it's all in one line, you don't really need to backtrack at all. Your estimation should always get you there. Interesting. see. All of this seems to be correct. Otherwise, we would run into this exception. Positions. Yeah. Hmm. Hmm. Can we speed this up anymore? iJob entity. Any type which implements this interface and also contains an execute method with any number of parameters will trigger source generation of a corresponding iJob chunk or iJob entity type. The generated job in turn invokes the execute method on the iJob entity type with the appropriate arguments. Any shared component or managed component as part of the query entity manager is generated. It's needed to access the components from the batch. This also means that type of job has to run on the main thread. Okay, that shouldn't be the case. We're only using components. Are there any other kinds of systems or jobs? Component system concepts, systems. The system provides the logic that transforms component data from its current state to its next state. For example, a system might update the positions of all moving entities by the velocity multiplied by the time interval since the previous update. A system runs on the main thread once per frame. Systems are organized into a hierarchy of system groups that you can use to organize the order that systems should update in. You can create either an unmanaged or managed system in entities. To define a managed system, create a class that inherits from system base. Oopsie. To define an unmanaged system, create a struct that inherits from iSystem. That is what we do here. But systems overview. Both iSystem and system base have three methods: an override, on update, on create, and on destroy. Systems on update method is executed once per frame. A system can only process entities in one world, so a system is associated with a particular world. Can use the world property to return the world that the system is attached to. By default, an automatic bootstrapping process creates an instance of each system and system group. Bootstrapping creates a default world with three system groups: initialization, simulation, and presentation. By default, an instance of the system is added to the simulation system group. You can use the update in group attribute to override this behavior. To disable automatic bootstrapping process, use the scripting define disable automatic bootstrapping. System types. System base provides a base class for managed system, provides iSystem provides an interface. For unmanaged systems, entity command buffer system provides entity command buffer instances for other systems. This allows you to group structural changes together to improve performance for your application. Component system group provides a nested organization and update order for systems. System groups. A system group can have system and other system groups as its children. A system group an update method that you can override, and the base method updates the group's children's in a sorted order. More information, inspecting systems in the editor. Okay, let's check command buffer overview. An entity command buffer stores the queue of thread safe commands. I think we've been here before. Temporary entities, entity command buffer safety, ways to schedule data changes. Use an entity command buffer. Yeah, this is the same out of date thing that we had before. I don't think this is correct though. This doesn't seem right to me. You can record ACB changes on the main thread, such as the following situation. No, that's not what I want. Parallel jobs. Entity command buffer playback. To split the recording of commands in an entity command buffer across multiple threads in a parallel job, it means that the order of the commands is non-deterministic because they depend on job scheduling. Determinism isn't always essential, but code which produces deterministic results is easier to debug. There are also networking scenarios which require consistent results across different machines. However, determinism can have an impact on performance. So you might want to accept non-determinism in some projects. Deterministic playback in parallel jobs. You can't avoid the non-deterministic order of recording in parallel jobs, but you can make the playback order of the commands deterministic in the following way. Record an int sort key passed as the first argument for each ECB method. Use the sort keys to sort the commands on playback before Unity performs the commands. I do add the sort key. The recorded sort keys are independent from the scheduling, then the sorting makes the playback order deterministic. Also, Unity will always play back commands with larger sort keys after commands with smaller sort keys. In a parallel job, the sort key you need for each entity is a number that has a fixed and unique association with the chunk in the jobs query. I don't really need this to be deterministic. So, could I omit this? ECB, the component enabled, but it always wants this. Or do I not use the parallel writer in that case? Let me try this again without the parallel. Oh, wait. Then this doesn't need to be here. Let's see if that works. Let's reduce the number of nodes. Okay, so this works. Let's use 32 as a benchmark. All right, let me save this and revert and see if this changes anything. So that was, wait, execute this again. So this is 25, 26, 27, 37, 38. So, or let's look at this actually. 30 to 33-ish, 34, 35. 30 to 35-ish. And if I do that with a parallel writer, I would expect it to be slower. Pretty much the same actually. 30, 35, 33. Yeah, pretty much the same. Oh, so that doesn't really change anything. And let's do the thing. Oh yeah, I can also, I don't need this. Use the normal ECV. Oh, this is much slower now. Oh, not anymore. 30, 29, 31, 36, 34. Yeah, pretty much the same. Pretty much the same. If I put a burst compile on the system and maybe on here, does this change anything? I'm never sure where to put the burst compile attributes. Should I just put them everywhere? Everywhere that accepts it? Okay. See. A star. Oh no, it doesn't run at all. Huh? The fuck? That doesn't seem right. Why is this still at 30 milliseconds? But this doesn't do anything. What? Excuse me? And it still runs, but it doesn't show anything here. Huh? Hmm. Didn't really change don't think. Huh. So maybe I don't do this? Because Unity gets confused? Maybe I put a burst compile on here on this method? I don't know. Okay, now I see it again. Yeah, same-ish as before. If I put a burst here. Oh, by the way, do I have to also put a burst compile on these methods? Let's see. No, that doesn't change anything. Actually, maybe a little bit. It's hard to say. I do hit 28 now sometimes. Hmm. Hmm. Does it make a difference if I have these functions in a separate static class or in my job in terms of burst compilation? If I put all of this here, for instance, and I just do a find path like this. Functionality wise, it's the same. Just want to see if that changes anything for the burst. OMG Unity. Hi, larger? Yaja? How do you pronounce it? Is it an L or an I? Welcome. No, that doesn't change anything. Okay, interesting. Yeah, I was getting frustrated with Unreal, so I'm doing some Unity stuff. Okay. So that didn't change a thing. What are you making? I am trying to how do I explain this? You probably know RimWorld and how you can only have like so many pawns without the game uh dropping to a slideshow. And I'm essentially trying to see how many pawns like in RimWorld I could simulate while keeping the frame rate stable. So I've created a system that does pathfinding, and I'm trying to see how many, um, yeah, how much pathfinding I can do in one frame. So far, let's actually see. So I'm currently simulating 100 pawns on a 32 by 32 map, which is about 30 FPS, with every pawn looking for a path on every frame, which is not how that would really work. Like 20, 25, 26. I reduced this to 50. This probably goes up. 48, 46, 50. I will probably have to do the same in game. Yeah, well, it's worth exploring. Now we are at 12 to 17. I'm not looking forward to that. And it's a lot of experimentation. Okay, so 25 is not a problem on a 32 by 32 map. It was like 80. Let's see, if I was like 64 by 64, this takes a moment to initialize. I'm currently not rendering anything. But the map is set up like standard 2D orthographic map. So you got 64 by 64, so 4,000 nodes in total. And then it already drops to 25 FPS. F25. I'm looking for 25 paths per frame, which is still quite a lot, to be fair. In reality, I think if you have maybe 100 pawns, you'd be looking like not every pawn would be looking for a path on every frame. Would be more like, yeah, it really depends on how long the actions are. Every pawn would look for a path maybe once every maybe 2 to 3 seconds. So it'd still have like 33 paths per second. That's still quite a lot. Okay, so 10 is already quite good. But I want to say we can probably make this faster. I'm still not sure about this. This command buffer thing still doesn't seem correct to me. It says to playback after I scheduled my jobs. Actually, let's try something. Is there a way to force this to be single threaded? Command buffer, systems, system comparisons. Okay, let's see. What's this? To create a system, you can use either iSystem or system-based. iSystem provides access to unmanaged memory, where system-based is useful for storing managed data. You can use both system types with all the entities packaged. With all of the entities packaged in the job system, the following outlines the differences between the two system types. Differences between systems. iSystem is compatible with burst, faster than system-based and has a value-based representation. In general, you should use iSystem over system-based. Okay, we're already doing that to get better performance benefits. However, system-based has convenient features at the compromise of using garbage collection allocations or increased source generation, compile time. Following table outlines the compatibility. Burst compile. Also, system-based doesn't have burst compile. Unmanaged memory, GC allocated, can store managed data directly in system type. Idiomatic for each. What is idiomatic for each? System query. Does it mean I could just do a for each and get the same effect? System API query. Oh, one more thing I could try is an aspect for my pawns, so they would be maybe faster to find. Also, the nodes are still just flying around, so I might want to try put these in a buffer. Job with code, entities for each. Entities for each use in system base. I see. iJob chunk entity, iJob chunk, iJob. So what's the difference between these two? iJob entity, any type which implements this interface is also contains execute. Yeah, remarks if yeah, okay, that's I already know that. iJob chunk. iJob chunk is a type of iJob that iterates over a set of chunks. For each chunk, the job runs on the job code receives an archetype chunk instance representing the full chunk plus a bit mask indicating which entities in that chunk should be processed. Schedule or run an iJob chunk inside the on update function of the system-based implementation. When the system schedules or runs an iJob chunk job, it uses the specified entity query to select a set of chunks. The entities in each chunk are examined to determine which have the necessary components enabled according to the entity query provided at schedule time. The job struct execute function is called for each chunk along with a bit mask indicating the entities. Okay. Pass data to an execute function beyond the execute parameters at public fields to the iJob chunk struct. Yeah. Hmm. What is this? Iterate over component data. Hmm. System groups, manage systems, multiple worlds. Working with system, access data, schedule data changes, ways to schedule data changes, command buffers. Yeah, okay, I've been here before. Access data, way to access data. How you access data in a system depends on whether you have used a managed system or an unmanaged system. The following are ways of accessing data in a system: system state, system base, system API. System state. I already know all of this. System information dependency. Workflows, convert data, use the job system in entities. Okay. Scheduling background jobs with code. The job with code construction, the system-based class runs a method as a single background job. Nah, not what I want. Job dependencies. No. Transforms and entities, blob assets, locators, performance and debugging, entity profiler, structural changes profiler, entities memory profiler. We could try and use the profiler to see where we lose the most time. Analyzes, profiler, entities, structural changes, memory, entities memory. Hmm. Let's let this run for a moment. We do have some garbage allocations. Simple, detailed. Ah, shit, I need the memory profiler package. Ah. Okay, detailed. Memories. I installed it. What are you saying? Analyzers, profiler. Please use the memory profiler package. Take detailed snapshots. Okay, is this different now than it used to be? Okay, let's run this for a moment. It's actually been a while since I worked with Unity. Been working with Godot for the past year. Memory profiler. Capture new snapshot. Hmm. Everything takes a while. Uh, but even with the burst compilation, the compiler is faster than in Unreal, so that should tell you something. Okay, so now I created a snapshot. But it doesn't. Ooh. Hey. Okay, so now we have this summary unity object, of memory. Yes, that's just the memory that I've allocated, but I'm not really interested in that. Hmm. Hmm. Oh wait, that's because I have selected the memory thing. Dum. Runtime. Right. Entities, memory, structural changes. Runtime content manager. CPU usage. That's really what I'm interested in. Okay, let's see. Select the frame. Clear loop. Simulation system group. A star system. Job handle complete. Wait for job group ID. A star system job purpose. Playback. Negligible entity command buffer. Negligible. So all of this isn't actually super important. Run. Okay, yeah, run is executing the thing in on the main thread, and schedule. Oh, schedule parallel? Maybe I haven't even multi-threaded this the whole time. see if this is any different. 22 ms. Ah, yeah, we need to create a map. Maybe I should optimize that a little bit. Invalid operation, job data ACB is not declared read only. What? Job parallel, the container does not support parallel writing. Okay, so now I need the parallel writer thing. Parallel. So I bring back all my changes as parallel writer. And then I need the chunk index in query thing again in index. Okay, yeah. Now we only need half the time that we needed before. We were at like 20 something milliseconds. Now we're at 10 something. Almost at 60 FPS on 64 by 64 for 10 paths per frame. So that's definitely a lot faster. Okay, so this has to be scheduled parallel. Let's see, can I optimize anything in here? So one thing that I could do is turn the 3D node into a 2D node. I don't know how much that actually helps. I mean, the distance calculations are a little bit simpler. Wait. Graph load 3. Graph. This guy. I'm also creating a graph on every execute. I don't think that's correct. I should really only create this graph once. Yeah, actually, I could create this graph once on startup because I'm not changing the nodes. And even if I'm changing the nodes, I would just recalculate the graph then and there. And I don't have to do that every time I want to do a lookup. Let's see. If I let's comment this out, and I say read only this guy, and I put this up here. And I do a graph equals graph. I would expect this to be at least a little bit faster, because now I don't do it on every execute, just once every frame, which is still too much. The graph should actually be a singleton entity, huh? Maybe. Actually, not much faster, but a little bit. I think we sometimes dip below 10 milliseconds. No? So let's see this graph. I'm just gonna make this static for now. I'll make this as ugly as possible. And I make this on start. And then a star system dot graph is graph. We just set this once. And I need entity manager get buffer. Can I get a lookup? It's a buffer lookup object that can access a dynamic buffer. Um, Can I get a component lookup? Component. Can I get any type of lookup? No. And I need. Need a component lookup. Make distance. I need a buffer lookup. So the node values. I need for getting the distance. How do I get? There should be a way to get a lookup. Maybe. Wait, maybe let's check system API. Doesn't show me how it's implemented. Buffer. Maybe let's see buffer lookup transitions. Can I instantiate this? Doesn't have any arguments. No static methods. Buffer. Create singleton buffer. Creates and supports only a single entity with a given unmanaged component buffer. I buffer element data. Create singleton buffer. I buffer element data. Let me check the docs for this. Buffer lookup. Okay. Nothing very helpful. Then let's ask Google. Buffer lookup. There's something here. Native container, yeah. Buffer lookup is a native container, blah blah blah. To get a buffer lookup, call get buffer lookup. Yeah, that makes sense to me. But okay, this is only in system API. Why is it only in system API? Buffer lookup is a native container that provides error-like access to dynamic buffer components of a specific type. For example, while iterating over a set of entities, you can use buffer lookup to get and set dynamic buffers of unrelated entities. Pass buffer lookup container to a job by defining a public field of the appropriate type in your job implementation. You can safely read from buffer lookup in a job, but by default you cannot write. Yeah. You know that two instances, blah blah blah. Get buffer lookup. Oh wait, maybe I can do this on create public void on create. Wait. Void on create like this, and then the graph. Oh yeah. Need also this. So now I've created the graph once. And this just goes into every job like this. And I don't have to get the lookups on every frame. So maybe that will be a little bit faster. Invalid operation exception attempted to access the component lookup node code 3 job, which has been invalidated by structural change. This that may be because because the system gets created first, and then this start runs. Let's see. Debug log stress. Oops, wrong key combination. And system. Hmm. Yeah. So the system gets initialized first. Is there perhaps an easy way around this? Maybe if I turn this into an await. Otherwise, I would have to implement something that creates the graph every time the nodes change. Still, okay, maybe we can touch with the execution order. Event system player input. Doesn't say anything about ECS. So if I put this at the very top, otherwise, I would have to make this a single entity, which is probably the proper way to do it. But I'm looking for the quick way to do it, not the proper way. Okay, yeah, no, this doesn't work. Okay. Okay then. Put this back on start. I could also okay. spatial. So we make this. Oh wait, can this even be? No, this can't be an entity, huh? Because these are not. Oh no, this is a component. This is also a component of our element data. An interface for creating structs that can be stored in dynamic buffer. Buffer lookup. Okay, so this is not a component. Buffer lookup. Component lookup is a component. Hmm. Hmm. Maybe this just doesn't work. Maybe I have to create this every frame. Get buffer lookup. I mean, this lookup is just for the entities. Doesn't really. It gets a lookup for the entities with these no transition buffers. So that doesn't really cost anything to create, at least not a lot. There's no, I don't think there's any calculation that needs to be done in there. The component lookup, probably the same. So maybe this is also just unnecessary, but I don't know. I'm not sure. I cannot make this an entity because the buffer lookup is not component data. Component lookup is component data. Hmm. Okay, no, I don't think I can change anything here. At least I don't see how. But doing this is definitely a bit cleaner. Let's check the A star implementation. Priority queue. Oh yeah, I had to implement my own queue. Let's see if this is okay. Native list, native hash set. And wouldn't you use a... You could use a tree, a binary tree. Count is empty at prior at priority node index. Okay, so this seems to use a binary search to look for the place to enter this. I don't think this is the best way to do this. Node n priority. Also creating lots of structs here. Which maybe is not necessary. Look up. Contains EQ. Insert in list. Okay, so open set. We start with the start node, obviously. Priority 0. Native hash map came from G-score. My cup is empty. G-score, F-score. Find path. So this is just standard A star. And EQ. And equals score, reconstruct path. Transitions. Get transitions for each transition. The current neighbor. The weight of the edge from the current neighbor. Tentative G-score is the distance from start to the neighbor through current. That is. Oh, this is the tentative G-score. Get entry G-score transition. This path to neighbor is better than any previous one recalled. Open set contains transition. If I do a Dijkstra instead, let me look up the Dijkstra. I did this just recently in a lecture. A star Dijkstra. Dijkstra's algorithm finds the shortest path of a node to all other nodes. Hmm. At least that's the algorithm I have right here. So with Dijkstra, I would calculate all the possible paths on the map, which could be quite a lot. Hmm. And then store them. Even with only like 100 nodes, I think that would explode very quickly in terms of the data that we have to hold. Hmm. But this priority queue may be better as a min heap. Min heap. Insert is block 10. Full binary tree. Added up until they are bigger than their parents. Shouldn't it be smaller? Oh no, bigger is correct. So if I were to do a min heap, then I don't really need the priority, so creating an extra struct here. Oh no, I do need the priority to compare with the new ones that come in. Okay, let's try to do a min heap instead. Min heap. So this would also be a struct and disposable. Note. Dispose. And we need I have this hash set to look up if we already have a node. Let's do it simple. We just have this list. And we could say maybe it's even an array. Not quite sure yet. But we definitely want this. Min heap. List. This. And in the end, we want to dispose the list. And then we do an add, similar to this one. And wait, to do a min heap in an array, I have to wait, to add, I have to add it in the, oh yeah, I add this to the end, and then I compare with the parent. And if it's smaller than the parent, then I swap. So I have to get the parent index, get parent index, int child index. The parent index is child index divided by 2. Child index divided by 2. And 0 has children 1 and 2. Or maybe it's -1 divided by 2. Because the children of 0 are 1 and 2. So 1, 2 -1 plus 1 divided by 2 is 0. The children of 1 are 3 and 4. 4 minus 1 is 3. Divided by 2 is 1. 3 minus 1 is 2. Yeah, I think that's correct. Children of 2 are 5 and 6. 5 minus 1 is 4. Yeah, that checks out. So we get the parent index. So we get child index is list length -1 because we just added it. And then we have to do a while something. also maybe until. We need the parent index equals get parent index of child index, and while list child index priority is smaller than list parent index priority, then we do this kind of thing. Let's swap them around. I wonder if I also have to add a burst compile here. Maybe actually, yeah. So I swap them, and then I have to set my child index to my parent index, and my new parent index is get parent index, child index. And that is everything, I think. Then I need a contains. I will just do this as a for each node in list. Right. Priority node equals n, return true, otherwise return false. Node. What's the issue? Oh, I think I need dot equals. Yeah. Equatable, yeah. Equals n, then that's true. I need a DQ. Which just removes the first element and then moves everything up. No, it doesn't move everything up by one. We have to get the smaller child and then move that one up and then get everything from below that to move up as well. List 0, return that. We don't actually want to remove that. So I need two more methods. Get left child index int parent index. The left child is just parent index times 2 plus 1. Yeah. And the right child get right child index is plus 2. Times 2. Plus 2. Yeah. So we get child, and we need the right child. And left child index and right child index. And then we compare both if list left child index is smaller than list right child index, then we want to move. Oh yeah. Dot t dot then we set the parent index equals 0, parent index, parent index, parent index. The list of parent index is equal to left child, otherwise it is equal to right child. And then we have to do this until we have no more children. And we also have to check if we only have one child. We don't have a right child, then this is always a full tree. Not a full tree, but what's the word? A complete tree. We can at worst have no children or only left one. So we also have to check. Node left child is this. And for the right child, oh no, I also have to check for the left child. So if left child index is greater or equal to list length, then we do nothing. At this point, we just return. Return in. I guess this is a loop anyway, so we would break. And then we get the left child, get the right child, and if the right child is outside of the array, then we also break. And if oh no, we don't just break here, we have to do this. We exchange, we move the left child up to where the parent was. And if both children exist, we do this comparison thing. And then our parent index is either the left child index or the right child index, depending on what we swapped with. And we do all of this in a while. Technically, while parent index is smaller than list length, but if we have no children, then this is if we only have one node, and I don't think this works. Oh, and also if our length is 0, then we should just throw an exception. List is empty. Throw a new invalid operation. Let's see. If we have one node and parent index is 0, which is smaller, maybe this should be a -1. Then this is equal. Yeah, I think that checks out. So if we have one child, then our list length is 2. Parent index is 0. 2 minus 1 is 1. 0 is smaller than 1. Left child, we do have if we don't have a left child, then we just break because we have no children. Left child. It doesn't need. Oh no. Left child. This and this and this. And we also need the right child. Right child index. Right. Then we swap, and the new parent index is where the child came from. And we go back here. So say this is 1. And then parent index is 1. Our list length is still 2. -1. Yeah, that would then break. As in exit the loop. I think this should be correct. And that's all we need. So I should make an interface for this. A star priority queue. Let's make an high priority queue. interface, and this has disposable and add. Oh yeah, this also needs this note where that, and we need the contains, and we need the DQ. Right, we only need the note here. N dot note. Or do we? Note. N dot note. This 0. So yeah, this is actually a lie. Removing is O of n because we have to move everything to the left. Contains DQ. So then this can be I priority Q. Oh yeah, and we have to implement this interface. I priority Q. Note. And also here. Oh. What? This. That should be okay. And then this works just fine. And then I have to change. Wait, what? Open set, find path. This is the one. Open set. Oh yeah, we also need an is empty. This guy. Bool is empty. Wait, this needs to get. Like so. It's empty DQ. Okay, yeah. That seems all right. So before I use this, I'm gonna just test it. Oh yeah, wait, this needs is empty. List is empty. And then an applied script execution order, apply. And then I have to write a test or two to check that my min-heap works. Tests. Oh, I already have priority queue tests. So I would think that I can just reuse these. Firstly, I'll have to uncomment this. This is why I returned the priority node, but actually let us do let's just instantiate these first node this, and then whatever we dequeue should be first node. We also have two of the same. Let's not have two of the same. Actually doesn't matter a whole lot. So this would be second node. Oh, wait. This and that. Then we have the 1/3. Then we have number 4. Fourth node. And then we have number 5, which is here. Fifth node. That should be that. Random priority queue test. Oh yeah, using is now also shorter. Don't need the braces anymore. Lists. You can tell this was written with an older C# version. Random value sort. And I'm comparing the priorities. Maybe I will just make these enumerable. Let's ignore this test for now. This works, then should be good enough now. Oh. Okay. General test runner. Q test. Okay, that works as expected. And then I'm gonna do min heap test, min heap. Where's my min heap? Oh, this is internal. Min heap. Actually, is there maybe already a min heap in C#? System selections heap? No, actually no. We do this. That also works. Okay. So that implementation seems to be correct. So then we can use it in here. A star min heap and see how that performs in comparison. This should be a little bit faster because removing now is only O of n, O of log n. It was O of n in the priority queue. Adding is probably about the same. The lookup actually just checking the array, not using a dictionary, might actually be faster because we're talking about very small arrays here. Usually very small arrays. Maybe I should speed up the map creation. Or are we just dead? Are we maybe just dead? Seems a bit long. Yeah. Something is not right. EQ. Maybe we need one or two more tests. Let's change this to priority queue. So at the end here, we can also assert this through queue is empty. That may be a problem. Hmm. First error can't call the method dispose on generic interface. Here, this may be because you're trying to do a for each of a generic collection. Type I numerable. Okay, Burst is not happy with the interface, which is fair, I guess. So, then we have to use the explicit type. All my windows are gone again. Test runner. No, Q. Oh yeah. So it was exactly what I thought. Is empty is never true. List is empty. DQ. Oh, we have to remove the last index. Is it always the last? Yeah, we have two children. Oh wait, is that even everything I have to do? And I remove the top node, and I only have two children. Then I may have to swap the right one for the left one. At when we add a node, the first one always goes on top. The second one goes on the left. Yeah, we always fill it up from left to right. But the first one is 0, second one is 2, the next one is 1. 0, 1, 2. We remove 0, 1 goes up. And then the 2 has to come to the left. Doesn't it? Right. Let me check my other implementation. I remember I did this a while ago. Oh shit, I don't have it on here. Then I will just look it up. Min heap C sharp. Priority queue. Min heap. Just give me some pseudocode. -1. Yeah, this is correct. Insertion. To insert an element into the min heap, we first append the element to the end of the array, then adjust the heap property by repeatedly swapping the element with its parent until it is in the correct position. Yeah. So this one is correct, I want to say. Yeah, otherwise the sorting wouldn't work at all. The removing. Actually, the removing should also be correct because we're testing that also. I'm missing something in my thought. Why do we never have to swap the right one for the left one? Insert. Delete. Removing the smallest element from the min heap. The root is replaced by the last element in the heap. Ah, that is the step I'm missing. The root is replaced by the last element in the heap, and then the heap property is restored by swapping the new root with the smallest child. Okay. So I don't compare the children. I mean, I do. But before I do that, I have to swap the root node with the last node. So we say list and index is list the last one. And then we can already remove remove at. List length -1. I don't think I can do this in here, can I? No, would be too convenient. So we swap the root with the last one, and then the root is replaced by the last element in the heap, and then the heap property is restored by swapping the new root with the smallest child until the parent is smaller than both children, or until the new root reaches a leaf node. So the root node is swapped with the smallest child, or we are a leaf node. So if we don't have a left child, we reached a leaf node. If we don't have a right child, oh, actually, if we don't have a right child, we still have to compare with the left child. If, oh, we, yeah, also have to compare the parent. Wait. If we do have a left child, then we say left child priority is smaller than parent. List parent index. And then we have to swap the parent index list parent index and list left child. Just left child. No. Left child index. Swap these. And then break. Because then we definitely reach the leaf node. Before the left node, the left child was on leaf node, and then the previously parent node becomes that leaf node. And if we have a right child, then we want to swap with a smaller one. Yeah, swap with the smallest child. But let's see, if the left child is smaller than the right child, then we still have to make sure that the left child is smaller than the parent. So we still have to do this. We swap, and parent index becomes left child index. And Um, Otherwise, if else, fuck. Um, have two children. Left child smaller than right child. Then if the left child is smaller than the parent, then we swap the left with the parent. And if left child is not smaller than the parent, if the left child is not smaller than the parent, then the right child also can't be smaller than the parent. So otherwise, when the right is smaller, am I doing this right? The right is smaller than the parent, then I swap these. Yeah. Is there a case where I would not swap with the smaller child? No, no, that doesn't make any sense. Okay, so I think this is correct. Right child priority, right child index, right child index. Okay, so this should be it. Parent index starts at 0. This is our result, no matter what. We set the root to the last item in the list. We remove the last item in the list. And then if we have no children, then we just stop. If we have a left child and no right child, then we check if we swap with the left child. And then we break in any case. And if we have two children, we check if we swap with the smallest child. And that should be it. Yeah, that seems to be okay. So this is correct. Um, yeah. Yeah, let's check with the priority list. Oh, no, I'm on the right scene. Actually, I'm gonna make the map creation a bit faster. This is taking too long. Let's test. All we really gotta do is have a private dictionary of int call it tiles new int to entity, and in here all we gotta do is return tiles xy oh yeah, this needs to be this. And then when we create the nodes, we just say xy equals e, and that should speed it up by quite a bit. Yeah, much faster. Okay, I need my system window. System. Okay, A star system sits at 9 to 20 sometimes, more like 9 to 17. Yeah, around 9 to 17. And actually, let me check one more thing. Do I add burst compile to all of this? I don't know if this does anything. Burst. There was an error. Huh. No, that doesn't change anything. If anything, it became a little bit slower. That doesn't seem right. Hmm. Okay, then let's check with the min heap. Min heap. What's this? Unsupported return type. Oh, I didn't. Wait. Hmm? Priority queue 24? Hmm? 24? Huh? Fuck? Unsupported return type priority queue, not for 3 for function priority queue, 1 create. Structs cannot be passed to or returned from external functions in burst. Ah, this one is not okay. Okay, are we good? Oh, we're stuck again. Something is still not right with the min heap. Fuck. Something is still not correct. Huh. A star. Wait, where was my A star test? Here. A star. So that probably also failed. Just gonna see. I do this. This goes through. So does this. Does this. Hmm. No, this is all okay. Yeah. Okay, something is not right with my min heap that I'm not checking for in any test. What could that be? Hmm. Okay, let's make a bigger test. Big test. And we're gonna do something like this. We need let's copy this. Let's just say this is 32 by 32. And we want to create like this dictionary. It's want to do something like this essentially. Don't have an entity manager. Don't really need the list. Want to create yeah. So this would be that, and then we just do this. Yeah. And then what we do is go through all of this and do something similar with values. We need a dictionary like this, neighbors. Don't need the dynamic buffer. The position is already in here. Oh wait, this is let's actually do a key value pair. Position is, yeah, it doesn't really matter. Like the key. Yeah, no, we need the value because this already gets the value, get node at position. It's just tiles. This and this is a node float 3, and then we add to our neighbors. First we need neighbors. Can this be a list? Or does it have to be an array? Has to be an array. Okay, then we say neighbors AVP value is new node 4. And then yeah, no, wait. We just create a temporary list of node 3 neighbors view neighbors at n tiles position value -1. Yeah. This needs some brackets. Okay. Tiles. Oh, neighbors at this. Okay, so now I just gotta do neighbors to array. Then we have everything connected. And that should be everything. Make our graph. Do our A star. And we want to go from tiles. Let's go from 0, 0 to 10, 10. And then we should get a path of how many steps? 20? And then we also gotta dispose. Okay, let's see. So I would think that this also crashes us at some point. we're doing pretty much the same thing we do at runtime. Yeah, this already seems to be the case. So what we can do is we attach it to Unity. And then we just say pause. And then I gotta find out where we see current stick trace. Right, we have to be somewhere in here, no? And if we add a thing here, it's one of the while loops. It's always one of the while loops. And this could be the issue. This could be the issue. Okay, yeah, we are in here. Parent index is 0. We're not updating the parent index somewhere. Parent index is 0. Left child index. List length is 3. Left child is 1. Right child is 2. So we have 2 children. And wait, what's in our list? Items. We have the 0, 3, 0. We have 1, 2, 0. And 2, 1, 0. Priority 3, priority 3, priority 3. Ah, okay. So we are not any of this. So we are equal to our children. So let's just make this smaller equals. Then it should be. Oh yeah, I still have to. Can I? Oh no, I recompiled. Can I force this process out of here? If I set parent index to 10, then we're out of here. And can I set this to true? No. List. Is there a way for me to remove all these elements from the list? Local open set list length 0. No, doesn't like me doing that. Oh well, then I guess we have to kill Unity. and then restart. In a while loop, there's always one case that I miss, which leads to an infinite loop. It never goes well. But this should take care of it. When we're equal. Oh, wait. What happens when we are bigger or when we're smaller? Then the parent index never. When we are already smaller than the children. Yes, we could just say else if this and else just break. We are smaller than our children. Or that parent is smaller than children. And then we know we reached the end. And that should truly be it. Then we also don't really need this. And save some swapping. Parent is smaller or equal to children. Yeah. I think that's right. Okay, general test runner. Big test. Okay. Expected 20, but was 21. Let's see. Test. No. 30 Q test. Then he test. Oh, a star test. This one was the one. If we go from 0, 0 to 10, 10, we go from 0, 0 to 1, 0, it's 1. If we go to 1, 1, it's 2. 1, 2, 3, 4. Yeah, it should be 20. Why is it not 20? If I do 1, 1, then it should be 2. But it's 3. Oh, because we also have to take in the start node. So 0, 0, 0, 0, 1, 0, 1, 1. So yeah, it's always one more. Okay, now that makes sense. That makes sense. So this is 21. So run all the tests and that works. And now the scene should also work, and it does. Not. We're hanging again. What the fuck? Uh, where are we hanging again? Hmm. Maybe I just can't find it because we're on a drop. Hmm. Okay, there's one more thing. Apparently. But what could that be? Restart test. Hmm. Hmm. Let's check a few more things then. Maybe let's do the no 31 to 31. Yeah, that's the longest path we can take, which should be 63. Window general test runner. Hmm, that works. Um, what else could we do? 15, 25 to let's say 40, no, 4 and 30. And that should be 11, 16, 30, 33. Oh no, it's 17. Way off. But that also works. Oh, I'm missing a dispose. I think I have to do that every time. Dispose. Hmm. Why would that not work? Go to, I don't know. I don't even know what to test anymore. Go to 31, 21, 10. Why is this 17? I have to go 11 down. Oh yeah, yeah, I was doubling it for some reason. I go 11 down, I go 5 up, which is 16 plus 1 is 17. So this is 30, 10, this should be 41. Hmm. This is still working. Why does it crash in here? That doesn't make any sense to me. Hmm. Okay, let's try something else. We just make a 4 in E equals 0, 100, and we do a random range unity random random unity random. I just want this here. Unity. Do I have to import Unity engine specifically? No. Huh? Oh wait, it's Unity engine dot random. Yeah, okay. No, flip it. Unity engine dot random range 0 to 32. 0 to 32. A bunch of random stuff. And then we just assert. Oh wait, we could do int start x int start start y int end x int end y. So this is start x and start y. This is end x and end y. And the length should be start x minus end x math. Yeah, any math. That's plus start y minus end y plus 1. That should be the length of the path. Convert. Oh, already compiled with the missing reference. Almost 4 o'clock. Almost time to stop. This still works. Why can I not reproduce the crash in my test? Ah, now we got it. Yeah, I think now we got it. So we're still in here. Parent index is 0. Our list is long. Right. Let's see list in here. Oh yeah, this list items 1 and 2, 37, 38, 37. Ah. So we go in here. Have a right child. So we compare left child. Left child is Okay, so in here, um, okay, so I guess we put a break at the end, and when we're in any of these, we say continue. It's a bit ugly, but what can you do? So when we found something to swap, we say continue. When we didn't find anything to swap, then we just break. Yes. This breaks. This there's a lot, a lot of breaks and continues in this loop. That's probably a nicer way to do this. I would say probably yes. Okay, so now we should be good, hopefully. Unless there's another thing that I missed. We still get stuck? No, no, we don't. Just took a moment. Okay, so then we should be good. Yeah. Okay, so we try this again. We now run this scene, which now should really work. Okay, it does. And it is slower than the priority queue. Entities, systems. This is, yeah, 12 to 21, 25. Yeah, this is definitely slower. Let's see. Um, let's see if putting first compile changes anything. Should also be best compile. Burst, 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 burst. No. No, this is just slower. Hmm. Intriguing. I would have thought this would be faster. Um. Hmm. Well, our add is log in. So is our remove. Adding here is also log in. Removing is n here and should be log n here. I mean, yeah, definitely this log in. And The only difference would be contains, which we use a lookup here. So let's see if the lookup changes anything. Lookup. Then when we add, we have to add it to the lookup as well. Note. And when we ask contains, we just return this lookup contains. When we dequeue, we want to say lookup remove res note. When we dispose, we say lookup dispose. And that should be all. Let's see if this still runs. Yes. Okay, then let's see if this is faster. No. I mean, a little bit faster, I think. We're reaching 11 sometimes. 11, 12, 13, sometimes even 8. Let's do a side-by-side comparison. Wait, how would I even do that? Could create another system that uses the other priority queue. And then I need to I need to somehow say which pawn should use which system. So I guess I could just say in find path component, set it to 1 or 2. So this is a star system. And we just copy this. Star system. Min heap. Min heap. And then I need a copy of this. Since we can't use the interface. No. I just doesn't let me remove the thing. Lead, yes. A star. A star. Min heap. A star min heap. And then I have to change this one back to priority queue. Priority queue. Priority queue. And this one uses a star min heap. And then I Um, put an int in here. Call it system. And say if find path system equals 0, not equal to 0, then we return here. And here we say if it's not equal to 1, we return. And then it's actually remove this. Don't think we really need it. Pawns count divided by 2. And we have to make sure that we have an even pawn count. Could you just let me look at the inspector? Thank you. One count is 10. And let's take this in here. I don't think we need this. Let's actually say I plus 2. We don't need this because we know on every frame this is being reset. And then we say pawns I gets this. And pawns I plus 1 this. And then we just say system equals 1. Oh, yeah, because it's a constructor. Let's just use new find path component node from node to system 0 and here it's just 1. Now both systems should be running with the same load. And then we have a direct comparison. System min heap. Yeah. The min heap seems to be consistently actually not consistently. Sometimes faster, sometimes it's slower. Huh. I think on average it's slower. Hmm. Let's add some more pawns. Maybe we can make the difference more more bigger. It is about the same still. Let's do 30. But the min heap is a little bit slower on average, it seems. Yeah. Hmm. Priority queue min heap. Even with the lookup. Hmm. I guess the remove is just faster. I mean this one, remove add. Because I suppose what happens is that the CPU can just take the entire array and move it over by one in one operation. Whereas for the min heap, it has to move one by one and be optimized. I think that's probably what's happening. At least that's the only thing that makes sense to me. Because this remove on paper should be slower because it's O of n complexity. Min heap is log n for removing. The insert. So this is just literally a binary search. Priority list index. Yeah, we compare with the middle. Next, we're bigger than the middle. Then we check the next element. And if the next element is bigger than the one we're trying to insert, then we found the insertion point. And otherwise, we just go to the next middle of the remaining. And then we just insert. Is there another self-sorting data structure that I could try? Binary search tree. binary search tree. But that's not, no, binary search tree is probably not the way to go, because that's not a complete tree. As such, it can't be represented as an array, I don't think. Okay, so the priority queue seems to be the way to go. I can't think of anything to make the min heap any faster. I really think it's probably all of this that's making it a little bit slower. Yeah, the sorting of the heap is probably the problem. Because for the queue, even when I insert something, this probably gets optimized on the CPU level. Insert range. Shifts element towards the end of this list, increasing its length. Oh, this was probably even faster. Insert range. Index. Index. Right, we start at index. Buffer B. List index. This is the one we insert. So we just increase this by 1. Insert range. Shifts elements towards the end of this list, increasing its length. So we can just say index equals n. And we don't need all of this. And this probably faster. Let's see my A star test. This is still using one with a priority queue. Let's run the tests. And then I think it's about to quit. Yes, save. Run all my tests. Yep, that works. Let's see, A star system. Yeah, priority queue is definitely faster. Seems like sometimes there's a frame where the min heap is faster, but on average The priority queue is winning out by quite a bit, actually. Like about 3 milliseconds, I want to say. Okay. So this should be all right. Okay. So I'm thinking what I could do next time. There's one more thing that should speed it up by quite a lot, which is grouping tiles together. It's a bit more complicated, but I think it actually does quite a lot because it reduces the number of nodes that you have to search. So when you have a rectangle of nodes that are all free and you just treat them as one, and you know that your pawns can walk straight through. So yeah, I think that's what I will do. Try to do next. But for today, I'm gonna cut it here and eat something. So I'll see you around. Bye bye.